Hello, this is Bob Golding again, Senior Escalation Engineer at the Microsoft site Charlotte, North Carolina. Today's video, we're going to talk about ODX. What does ODX do, and what are the advantages of it when a storage subsystem supports it? So, again, what is ODX? ODX is used to accelerate copies between disks. It uses something called tokens to send data to storage, so the storage can actually do the copy between the two drives or two LUNs. The I/O octals that are used to implement this feature are called CTL offload write and CTS offload read. And this is implemented in the file copy API. If the offload I/O octal fails, standard file copy is used. Now, the engine is also optimized, so if offload is not supported, it will not use offload again. It'll remember the volume, and when the next time a copy is attempted, it will not use offload. For example, if you want to copy 100 files, excuse me, it will fail on the first offload, and then the subsequent file copies will not use offload at all. Now, this is based on what errors returned. Certain errors may not cause this feature to be implemented. It depends what errors returned. Errors like not supported, for example, will cause ODX not to be used anymore. There are certain errors if a failure occurs and it's not in the the list of errors that we expect to get back. It may use offload write again. Now, the fact that the drive does not support offload write is remembered for the duration of the process, as long as the process image is instantiated, since the copy command is per process based, so that information is stored in a copy DLL. Now, here's a picture. Now, this picture is taken from our Microsoft documentation and basically how it all works. We do an offload read with information about the source. We make a request to storage to get a token. The token can be sent to another machine if it's a read or write across, if it's a copy across the network, and we do an offload write with token, and then we get the results back. But the actual data transfer occurs between the two LUNs, and the operating system is not involved. Traditionally, we'll do read from one file, write to the other, read from one file, write to the other. But in the case with offload write, we give the storage the responsibility of actually doing the copy. Now, what are some of the restrictions that on offload write? It needs to be supported by storage. Also, filters must support it. All the filters that are attached to volume must support offload read and write. And also topology. Both drives and LUN need to be accessible by the array software so you can do the copy between the two disk units. Like I mentioned before, filters need to advertise their support. There's a key in a registry that's per filter called supported features. It has bits to indicate if offload is supported, and the API is FSRTL get supported features. That is what the system uses to check the supported features, and there's more information in that API since it's documented about the feature bits. Also, there's a per file system a key called filter supported filters mode. It can be set to 0, and Windows will do the normal opt-in processing, or it could be set to 1. It will never use offload, and offload will fail, and it's equivalent to setting supported features to 0 on all filters attached. Now, what happens in the file system when it receives an offload offload read command or offload write command. The file system needs to flush all modified data to the media if cached. Now this is necessary because the the array actually does the copy. So the file system must flush all modified data to the media. And then it will send a IOOCTL storage managed dataset attributes to the class driver with the code either DSM action offload read or DSM action offload write, depending on the part of the transfer. Excuse me. Then class PMP, between the file system and the class driver, they'll create a block descriptor list based on the file system info on the location of the data being transferred, and partition offsets are converted to disk offsets. Then it sends a receive populate token to the storage. The read token information is sent back to the application, so it can be used in the offload write. And for the offload write command, class PMP read token along with a block descriptor list is sent to the storage. The storage does the copy. When the request is complete, a read token request is sent to the storage to obtain information about the transfer. The read token and write token, read and write tokens initial to request is complete or fails, and the number of requests depend on the size of the file. Now here's some information exactly about what happens in class PMP with a populate token or offload read. The class PMP will send a service action populate token with a transfer list. That command will complete. Then class PMP will send a receive raw token information command to receive the actual token. The token is received from the storage. Then it is packed back to the user to be issued in the offload write. On the offload write, class PMP sends a SCSI operation write using token. That command completes. Then class PMP issues a read raw token information command to get the transfer information. That command completes, and that phase of the transfer is completed. When the offload write is issued to the storage, the transfer is initiated by the storage, and when the write using token command completes, the command is the write is actually done and will receive raw token information to get information about the transfer. What about VHDs? VHDs do support offload read and write. Offload is handled by VHDMP in the host. The information is sent from the VM into the host, and the VHDMP will use the VHD file offsets and send the offload IOOCTLs to the file system. And the offload is actually done to copy sections of the VHD from LUN A to LUN B. So that's how it's supported inside VMs. The VMs will support it, and again, it also needs to be supported by the storage. More information can be found at this offload data transfer Windows drivers and Microsoft Docs, and I put the link also in the slide, and also you can find out information specifically about tokens, offload read and write, in the SCSI specification to find more detailed information about exactly how these commands work and what is required to issue the commands to the storage. I hope this helps with the understanding of ODX. Thank you for watching the video.